Hello and welcome to this summer 2023 practice paper. This one's for AQA Higher Paper 1. If you want to give the paper a try, you'll find a link to it in the video's description. You might also want to check out my website where you can see many other practice papers and also future dates for the papers I'm going to release soon. So we'll start with question 1. Here we have a circle that has radius 6 centimeters, so it will look something like this. We need to find the circumference of the circle in terms of pi. To find the circumference, you do circumference equals pi times diameter. So since the radius of this circle is 6, the diameter must be double that, which is 12. So we just need to do pi times 12, which gives you 12 pi. For this question we need to simplify. We're going to start with the m to the power 4 all to the power 3. When you have a bracket to a power like this, you can just multiply the powers, so 4 times 3, which is 12. So the top of this fraction is just 2 times m to the 12, which is 2m to the 12. And then we're going to divide by m squared. When you divide like this, you subtract the indices, so 12 take away 2 is 10. So the answer to the question is 2m to the power 10. In this question we need to work out 20% of £350 first. To do this, we'll do 10%, which is £35, and then if you double this, 20% will be £70. We then need to find 3/5 of 70. To do this, you do 70 divided by 5 first, that gives you 1/5, which is £14, and then take that £14 and times by 3, which gives you £42. So the answer is £42. In this question we need to solve this inequality. We're going to start by adding 2 to both sides. If you add 2 to the left-hand side, it will cancel the negative 2 that's already there, leaving you with 6x. And on the right-hand side we've got a 2x and we're adding 2, so that's just 2x plus 2. Now we'll subtract 2x from both sides. If you subtract 2x from 6x, you get 4x. And if you subtract 2x from the right-hand side, it will cancel the 2x that's already there, leaving you with 2. Now we can divide both sides by 4. If you do 4x divided by 4, you just get 1x. And 2 divided by 4 is 2 over 4, which simplifies to give you 1/2. So the answer to the question is x is greater than 1/2, or 0.5. For this question we're going to approach each of the brackets separately. Let's start with the first one. So we need to do 7/8 take away 1/4. To subtract fractions you need a common denominator. I'm going to go for 8, so the first fraction can actually stay the same. The second fraction though, I want to write it as something over 8. To get from 4 to 8 on the bottom I multiply by 2. So I'll multiply by 2 on the top as well. 1 times 2 is just 2. Now you can do 7 take away 2 to get 5, so the answer to this bracket is 5/8. Now let's look at the second bracket. This is just 2 1/4, and we can convert this mixed number into an improper fraction. We do 2 times 4, which is 8, and then plus 1, which is 9. So this is the same as 9/4. So since we're doing the first bracket divided by the second bracket, we can do 5/8 divided by 9/4. To do this, we'll leave the 5/8 as it is, change that divide into a multiply, and then take the reciprocal of the last fraction. So 9/4 becomes 4/9. Now we can just multiply. 5 times 4 is 20, and 8 times 9 is 72. And this one will simplify. If you divide by 4 on the 20 and the 72, you end up with 5/18. In this question we have a geometric progression. This means to get from one term to the next term you must multiply or divide by some number. In this case I'm going to approach it as a multiply. So what do I multiply to get from 1 times 10 squared to 3 times 10 to the power 4? Well, to get from the 1 to the 3 I can multiply by 3, and to get from 10 squared to 10 to the power 4 I multiply by 10 squared again. So to get from one term to the next in this sequence I just multiply by 3 and 10 squared. So what do I do to get the fourth term? Well, I take the third term and multiply it by 3 and 10 squared. So 9 times 10 to the 6 times 3 times 10 squared. In order to approach this, we'll multiply the 9 and the 3 together first, that's 27, and then the 10 to the power 6 times 10 squared. Here you would add the indices to get 10 to the power 8. In the question though, they ask for the answer in standard form, and this currently isn't in standard form because 27 is greater than 10. Remember, the first number in standard form must be between 1 and 10. So instead of 27, we're going to write 2.7. But to get from 27 to 2.7, you've just divided by 10. So you must also multiply by 10 to balance this out. So 10 to the 8 times 10, which is 10 to the power 9. So the answer is now in standard form, so it's 2.7 times 10 to the power 9. In the second part of the question, we've got an arithmetic progression instead. To get from one term to the next, you'll either add or take away. In this case, it's adding. So 1.5 times 10 squared is the first term, that's just 150. 5 times 10 squared, that's the second term, that's just 500. And the next term, 8.5 times 10 squared, is just 850. So it should be clear to see you're adding 350 each time. Now we need to work out the ratio of the first term to the fourth term. So to work out the fourth term, we'll add 350 again. That will take you to 1,200. So the ratio must be 150 to 1,200. But we need to give this in the form 1 to n. So we need to simplify. Let's divide by 10 first on both sides. That'll give you 15 to 120. Then you can divide both sides by 5. That'll give you 3 to 24. And then if we take that ratio and divide both sides by 3, we end up with 1 to 8. So the answer to the question is 1 to 8. In this question, we need to work out the shaded area, again given the answer in terms of pi. So we'll start with the square. The area of the square is just 10 times 10, which is 100. Now let's look at one of the sectors, the sector DEF, that's this one here. To find the area of a sector, you need to know its radius. Now in the question, we're given a ratio AE to ED is 2 to 3. Now if you double this ratio, you end up with 4 to 6, and you'll notice 4 plus 6 equals 10, which is the length of one of the sides of the square. So AE must be 4 centimeters and ED must be 6 centimeters. This means the radius of our sector is 6. So we can do pi times 6 squared, which will give you 36 pi. That's the area of the whole circle. But this sector is a quarter circle, so we'll divide that by 4, which gives you 9 pi. So the area of the sector DEF is 9 pi. Now let's look at the larger sector DAC, which is this one here. The radius of this one is the same as the length of the side of the square, so 10. So if we do pi times 10 squared, that's 100 pi. That's the area of the whole circle, and again we have a quarter circle, so we'll do 100 pi divided by 4, which gives you 25 pi. Next we'll try and find the unshaded area. That's this part here. To do that, we'll do the area of the larger sector, DAC, subtract the area of the smaller sector, DEF. So that's 25 pi, take away 9 pi, which is 16 pi. So the unshaded area is 16 pi. Now we can get the shaded area by doing the whole area, which is the square, which was 100, subtract the unshaded area, which is 16 pi. So the answer to the question is 100 take away 16 pi. A really common wrong answer here would be to give 84 pi, thinking you can do 100 take away 16. But the 100 doesn't have a pi with it, so we just leave it as 100 take away 16 pi. In this question, we're told the mean age of everyone in Martin's family is equal to the range of their ages. So we'll start by finding the mean age. To find the mean age, you add up everyone's age and divide by how many people there are. So let's add up all of their ages first. We've got Martin, who's 12. Martin's mother is X, and his father is X plus 3. So that's all of the ages added together, and we divide it by how many people there are, and there's 3 people in this family. So divide by 3. Now this must equal the range of their ages. To find the range of their ages, we do the biggest age, take away the smallest age. Now since Martin's mother is X and Martin's father is X plus 3, Martin's father must be older. So the oldest person is X plus 3, and the youngest is Martin at 12. So we do X plus 3, take away 12. This is now just an equation to solve. We're going to simplify this part here first by adding the two x's together and adding the 12 and 3. So that's just 15 plus 2x. And this is divided by 3. On the right hand side, we've got 3 take away 12 here, which is negative 9, so the right hand side is just x take away 9. Now we can multiply both sides by 3 to remove this fraction. If you multiply the left by 3, you get 15 plus 2x, and multiply the right by 3, you'll get 3x minus 27. Next, we're going to subtract 2x from both sides. On the left hand side, that'll cancel the 2x that's there, leaving you with 15, and on the right hand side, 3x take away 2x is just 1x, so it's x take away 27. Now we can add 27 to both sides. 15 plus 27 is 42, and on the right hand side this will cancel the negative 27, giving you x. So we find that x equals 42. In the question we were asked to find the age of Martin's mother, who happens to be x years old, so the answer is 42. In this question we need to use approximations to estimate the answer to this calculation. This usually means we're going to round to one significant figure. So instead of 1013, we'll round that to 1000. So on the top, we've got the cube root of 1000. On the bottom, instead of 0.21, if you round that to one significant figure, you get 0.2. so it's 0.2 squared instead. The cube root of 1000 is nice, it's 10, and 0.2 squared is 0.2 times 0.2, which is 0.04. So we need to do 10 divided by 0.04. If we multiply the top and bottom of this fraction by 100, it will remove the decimal. So 10 times 100 is 1000, and on the bottom, 0.04 times 100 is 4. So this is just the same as 1000 divided by 4, which is 250. For this question, we have a triangle which has been translated by this vector. So let's imagine we had a point on that triangle, we'll call it A. We're going to translate it 3 to the left, and then it's going to go 6 up. And then we'd end up here, which is the image of A. So we're asked to work out the gradient of the line connecting A and its image. To do this, we need to work out the horizontal and vertical distances. We just moved left 3 units, and then we went up 6 units. So to find the gradient of this, I'll do the change in y, which is 6, divide by the change in x, which is 3. So 6 over 3, which is 2. However, this line slopes downwards, so the gradient of it's going to be negative 2. For the second part of the question, we've got an enlargement by scale factor 2.5. So let's imagine we had the original triangle, and then one that's 2.5 times bigger. So to get from the small one to the bigger one, we would have multiplied the lengths by 2.5. We just need to work out what we multiply to get back. Well, let's rewrite 2.5 as an improper fraction. 2 times 2 is 4, and then add 1 is 5, so it's the same as 5 over 2. So going backwards in the opposite direction, you'd multiply by its reciprocal, which is just 2 over 5. So the answer to this question is 2 over 5. In this question, we're told that 19/20ths of the runners finish in under 35 minutes. This means that 1/20th of the runners took longer than 35 minutes. Now there are 120 runners, so we can find 1/20th of 120 by dividing by 20. 120 divided by 20 is 6, so 6 runners took longer than 35 minutes. And if there are 120 runners in total, 120 take away 6 is 114. So 114 of the runners finished in under 35 minutes. This means we can plot the first point on the diagram at 35 minutes at 114 runners. Now we're also told the time of the last runner was 40 minutes, so the final point must be at 40, and then the highest cumulative frequency for the final runner, 120. To complete the diagram, you just need to join up these points. You have 2 options here. You could use a smooth curve, or you could join them up with straight lines. Both will get you the marks in the exam. I usually recommend using straight lines since I think it's easier to do. For the next part of this question, we're told Daria finishes the race in 30th place, and we need to work out her time. To do this, we'll start at 30 on the cumulative frequency and draw a horizontal line across to our diagram. Then we'll go down from this point where it intersects, and read off the time. So I get a value of 21 minutes. In the exam there'll be some level of tolerance, so you may be allowed a value that's close to this, perhaps 20 or 22 would also be acceptable. In the last part of this question, we're told that runners who complete the race in 25 minutes or less win a medal, and we need to work out the percentage of runners that receive a medal. So what we'll do is start at 25 minutes on the bottom axis, and draw up until we hit the diagram, and then read across. So I end up with 48 runners here, and in fact that's exactly on one of the crosses plotted. So there are 48 runners out of a total of 120 runners who would receive a medal. To turn this into a percentage, we can first of all simplify this fraction. If you divide them both by 12, you end up with 4 over 10, which you should recognise as 40%. In this question we have 2 bags that contain coloured counters, and we're given some information in the form of ratios. We need to complete the diagram first, so if we look at bag A, the ratio of red to blue is 3 to 5. This means there's a total of 8 parts in that ratio, so the red counters must be 3 over 8, and the blue counters must be 5 over 8. If we do the same process for the next bag, we've got blue and green in the ratio 4 to 3. This time that's a total of 7 parts, so blue would be 4 over 7, and green will be 3 over 7. And it's the same for the bottom branches as well. Now we need to use this diagram to work out the probability that exactly one of the counters is blue. So we need to look for all of the routes where one of the counters is blue. So we could get a red on the first bag, and then a blue on the second bag. That has 1 blue. Or we could also do a blue on the first bag, followed by a green on the second bag. So these are the only routes that work. You couldn't have blue followed by blue because then there isn't exactly one counter. So we just need to work out the probabilities of these routes. To do this, you multiply the fractions along the routes you took. So the first route we did was red-blue, so we do 3/8 times 4/7, which gives you 12 over 56. Then we did the bottom route, which was 5/8 times 3/7, which gives you 15 over 56. Then we just add together those two fractions. 12 add 15 is 27, so it's 27 over 56. In this question, we're told some information about Tom's wins and losses before he starts the tournament. Let's call W the number of wins that he has and L the number of losses that he has. So we can rewrite this ratio as W to L, so wins to losses, equals 3 to 5. Now we're also told some information about what happens during the tournament. He wins 6 games and loses the rest. Since there are 8 games, he must lose 2. Then we're told the ratio of wins to losses after the tournament. It's now 3 to 4. So if W was the number of wins beforehand and he's won 6 more, that's W plus 6, and if he's lost 2 more, the number of losses is L plus 2. So we can write this ratio as W plus 6 to L plus 2 equals 3 to 4. We can now use fractions to rewrite these ratios. So the first one, we would write W over 3 is equal to L over 5. And for the second one, W plus 6 over 3 is equal to L plus 2 over 4. If we cross multiply on both of these, on the left one we end up with 5W equals 3L, and on the right one we get 4 lots of W plus 6 equals 3 lots of L plus 2. Let's expand the brackets on the right one, so that becomes 4W plus 24 and 3L plus 6. Now notice on the left one here we have 5W equals 3L. This means we can replace the 3L in the right one with a 5W, like this. We now have an equation to solve in W. Let's take away 4W from both sides. On the left hand side that just leaves 24, and on the right hand side W plus 6. Then subtract 6 from both sides. On the left hand side that's 18, and on the right hand side just W. So W equals 18. We were asked to find out how many games Tom won before the tournament, which we said was W, so the answer to the question is 18 wins. In this question we need to convert 0.017 recurring into a fraction. Let's start by saying x equals 0.017 recurring. Then we'll multiply this by 10, this will give us 10x, which will now equal 0.171717 and so on. Now at the moment the decimals don't line up here, so we'll multiply by 10 again. So now it's 100x, and on the right hand side here it would become 1.717171 and so on. So if you look at the lines here for 100x and 1x, you'll see that after a certain point all of the decimals line up. This means if we use these two lines and subtract them, we'll be able to convert this to a fraction. So let's ignore the 10x in the middle and do the 100x line take away the 1x line. 100x take away 1x is 99x, and then if we do the 1.7171717 take away 0.0171717, the bits that are highlighted will cancel out, and we're just left with 1.7 take away 0, which is 1.7. If we divide both sides by 99, we end up with x equals 1.7 over 99, and if we multiply the top and bottom by 10 here, we'll lose that decimal, and it will become 17 over 990. You can be sure that this one doesn't simplify since 17 is a prime number. In this question we're told that m is directly proportional to the square root of x. This means that m equals k root x for some constant k that we need to find. We've been told some values, m equals 20 when x equals 4. So if we substitute those values in, we replace the m with 20, so 20 equals, and then the x with 4, so k times square root 4. Square root of 4 is just 2, so we've got 20 equals k times 2, and then if you divide both sides by 2 you find that k is equal to 10. So we can just rewrite this formula that we wrote at the start, m equals k root x, but replace the k with 10. So m equals 10 root x. Now we're asked to find the value of x when m is 2.5. So let's take the formula from the previous part, and we can just replace the m with 2.5. So we end up with 2.5 equals 10 root x. If you divide both sides by 10, then we have 2.5 divided by 10 equals root x. Now 2.5 divided by 10 is the same as 1/4, so 1/4 equals root x. And then to find x you can square both sides, so we end up with x equals 1/4 squared. A quarter times a quarter is 1 over 16, so the answer is 1 over 16. Let's start this question by looking at the square root of 1 4/5. To do this, we'll turn it into an improper fraction, so 1 times 5 is 5, add 4 is 9, so that's the square root of 9/5. And we times this by 5 root 20. Now if you're going to do square root of 9/5, you could just do the square root of 9 divided by the square root of 5, and the square root of 9 is nice, that's just 3. So it's 3 over square root 5, and again times 5 root 20. You can now multiply these, so if we do 3 times 5, that's 15, so the top will be 15 root 20 and the bottom root 5. We can then use a surd rule. The square root of 20 divided by the square root of 5 is the same as the square root of 20 divided by 5. 20 divided by 5 is 4, so this is just 15 root 4. And the square root of 4 is just 2, so it's the same as 15 times 2, which is 30. In this question, we're looking for the coordinates of P, so we want to know this value down here and this value over here. This relies on you knowing some exact trig values. So you should know that sine of 45 is square root 2/2, and cos of 45 is also square root 2/2. So when we do sine of 45 and cos of 45, we end up with the same value, so this must correspond to the point P in this diagram. So the value of the angle, which is on the x-axis here, is 45 degrees, and the y-axis value is square root 2/2, which you may also write as 1/√2. In this question, we're going to try and draw the graph of y equals sine of x plus 90. Whenever you add a number inside the function like this, you're going to move it the opposite direction to what you might expect. So when you see a plus 90, you're probably thinking of moving to the right 90, but actually we're going to translate left 90 degrees. So let's draw the regular function y equals sine of x. That starts at 0, 0, goes to 91, 180, 0, 270, -1, and 360, 0. So y equals sine of x looks like this. We just need to move this left 90 degrees. So the 0 point will go off of our scale, and all of the other points we see move left 90 degrees. And then we'd also introduce another point at the end here. So the correct graph would look something like this. In this question, we need to work out the values of a, b, and k. Let's start with the line y equals a to the power x, and the coordinate a, which is 3, 8. Now if a has coordinates 3, 8, its x value is 3 and its y value is 8. If we substitute those values of x and y, as 3 and 8, into the equation of the graph y equals a to the power x, we end up with a to the power 3 equals 8. Now if a to the power 3 equals 8, we can just cube root this to give a equals 2. Now let's look at the point B, which has coordinates 6, k. We know this also lies on the line y equals a to the power x, but we just found that a was equal to 2. So the equation of the line is actually y equals 2 to the power x. And we know the x coordinate for point B is 6, so to find the y coordinate we do 2 to the power 6, which is 64. So the y coordinate of that point is 64, in which case k is 64. Now let's look at the point C, which has coordinates 2k. But we know that k is equal to 64. This point isn't on the same graph though, it's on a different graph, y equals b to the power x, and we don't know the value of b yet. But much like we did when we found a, we can substitute in the x and y coordinates, so we know x is 2 and y is 64. So we know that b to the power 2, or b squared, must equal 64. If you square root both sides here, you'll find that b equals 8. Now you might be thinking there's another solution here, b equals -8, but due to the shape of the graph, you can tell that b cannot be negative. For the second part of this question, we've got a different graph, y equals 5 to the power x. And we've been told a point that's on this graph, d, which is 3.5, p root 5. So we're told the x-coordinate is 3.5, so if we substitute that in, we get 5 to the power 3.5. 3.5 is just the same as 7/2, so it's 5 to the power 7/2. Now when you raise something to the power that's a fraction, the bottom number of the fraction will tell you the root you need to do, and the top number will tell you the power you need to raise this to. So since it's a 2 on the bottom, we need to do the square root of 5, and then do this to the power 7, which means the square root of 5 times by itself 7 times. Now each of these square root 5 times square root 5s here will give you 5, so that's 5, this one here is also 5, and this one here is also 5. So it's actually 5 times 5 times 5 times square root 5. 5 times 5 times 5 is 125, so it's 125 square root 5. So the y coordinate has value 125 root 5, and we've been told in the question it's p root 5. So you can see the value of p must be 125. In this question we've got some algebraic fractions to solve. We're going to start with the left-hand side and write each of these over a common denominator of y plus 2 and then 2y minus 1. So if we look at the left fraction, we need to multiply the top and bottom here by 2y minus 1. So on the top we end up with 3 lots of 2y minus 1, and on the bottom we've got a y plus 2, but we also need to multiply this by 2y minus 1. Then for the second fraction, we're going to multiply by y plus 2 on the top and bottom. So we've already got a 2 there, so it's 2 lots of y plus 2, and on the bottom we've already got a 2y minus 1, and we also need a y plus 2. And on the right hand side, this equals 1. We can expand out those brackets on the top of each of the fractions, so 3 lots of 2y minus 1 is just 6y minus 3, and 2 lots of y plus 2 is 2y plus 4. We can now combine these fractions into one fraction, so on the top we've got 6y minus 3 plus 2y plus 4, all over y plus 2, 2y minus 1, and on the right hand side equals 1. We can simplify this bit here. 6y add 2y is 8y, and negative 3 plus 4 is plus 1. So 8y plus 1. And if we multiply both sides by the brackets that are on the bottom, the left hand side will lose those brackets, and on the right hand side it will just be one lot of y plus 2, 2y minus 1. We'll leave the left hand side alone and expand the right hand side. Y times 2y is 2y squared, and then y times negative 1 is negative y, 2 times 2y is plus 4y, and 2 times negative 1 is negative 2. We'll leave the left hand side alone again and simplify the right hand side. We've got negative y plus 4y, which gives you 2y squared, plus 3y minus 2. And then if we subtract 8y and 1 from both sides, the left hand side will become 0, and the right hand side will become 2y squared minus 5y minus 3. So we now have a quadratic equation where one of the sides equals 0. So to solve this we just need to factorise or use the quadratic formula. This one fortunately does factorise. It becomes 0 equals 2i plus 1 and y minus 3. This will give you two solutions. We have 2i plus 1 equals 0, and then y minus 3 equals 0. The left one will give you y equals negative a half, and the right one gives you y equals 3. In this question we're told the probability of b equals 3/8. The probability of b would be the sum of the probabilities inside the b circle, which are these two here, 2x plus y. So 2x plus y must equal 3/8. Now we also know that the sum of all of the probabilities in the Venn diagram must equal 1. So if we add together all of these parts here, we must get 1. So we've got 3x and 4y, so 3x plus 4y must equal 1. What we have here is a set of simultaneous equations to solve. On the left one, it might make sense to multiply both sides by 8 first of all to clear the fraction. So if we multiply 2x by 8, we get 16x, and y by 8 becomes 8y, and 3/8 by 8 leaves you with 3. Now since this one has 8y, I'm going to double the other one so we also get 8y. So 6x plus 8y equals 2. So if we take this over here and subtract the equations, 16x take away 6x is 10x, 8y take away 8y is 0, and 3 take away 2 is 1. So we find that 10x equals 1, in which case 1x must equal 1 over 10 or 1/10. We can now substitute this back into one of the equations to find y. I'm going to go for the very first equation up here. So 2 lots of x, which is 2 lots of 1/10, which is 1/5, plus y equals 3/8. So to find y, I need to take away 1/5 from both sides, so y equals 3/8 take away 1/5. If you do this, you end up with 7 over 40. So we found that x equals 1/10 and y equals 7 over 40. We've been asked to find the probability of A union B, which is the sum of these probabilities here. These probabilities add up to 3x plus y, so we need to find the value of 3x plus y. So we know that x is 1/10, so 3x must be 3/10, and we know y is 7 over 40. To add these, we'll need a common denominator, so let's change the 3/10 into 12 over 40. Now we can add them easily. 12 add 7 is 19, so it's 19 over 40. In this question, we need to work out the volume of the cylinder, again given our answer in terms of pi. To find the volume of a cylinder, you need its height and its radius, and we don't have either of those yet. We do have a right-angled triangle here though, so let's use SOHCAHTOA to find some of those missing lengths. Let's label the triangle so we've got the opposite, the adjacent, and the hypotenuse. So using this information, we can write that sine of 60 must equal the opposite, which we don't know, divided by the hypotenuse, which we know is root 3. Sine of 60 is just equal to square root 3 over 2, so let's change that. And then to find O, we'd multiply both sides by square root 3. So we'd get square root 3 times square root 3 over 2 equals the opposite. Square root 3 times square root 3 is just 3, so the opposite, which is the height, is equal to 3 over 2. Let's also work out the adjacent. To do this, we could write that cos of 60 equals the adjacent, which we don't know, divided by the hypotenuse, which is root 3 again. Cos of 60 is equal to 1/2, so let's change that. And then to find a, we'll multiply both sides by root 3, so we just find that a equals root 3 over 2. So we've just found a, which is the diameter of the circle going from one side to the other. But to find the volume, we actually want the radius, which is only half of that length. So we need to half the value of a to find the radius, so the radius will equal square root 3 over 4. And we found the height earlier, but we called it the opposite, so let's replace the O with an h, so it's the height, which is 3 over 2. We can now use this height and this radius to work out the volume of the cylinder. So the volume of a cylinder equals pi times the radius squared, so we need square root 3 over 4, times another square root 3 over 4, and then times by the height, which is 3 over 2. We can tidy this up quite easily. Let's multiply all of the numerators on the fractions here. Root 3 times root 3 is 3, and times by another 3 gives you 9, and on the bottom 4 times 4 times 2 gives you 32. So we end up with 9 over 32 pi, which you could also write as 9 pi over 32. In this question we need to prove that y equals 2x. We're going to start by finding this angle here, AHE, which is also equal to x. And the reason is because of the alternate segment theorem. So we could write down that AHE equals x and give a reason, which is due to the alternate segment theorem. We're then going to look at this angle here, which is also x. The angle HEF is also x, and this is because of alternate angles. So the angle AHE, which we found previously, is an alternate angle to this angle HEF. So we could say that it's alternate to angle AHE, and alternate angles are equal. Next we're going to try and find this angle here, which is angle EHF. Notice we have a triangle here, and the angles in a triangle must add up to 180. So we know the other two angles, they're both x, so to find this angle we'll just do 180 take away 2x. So angle EHF is 180 take away 2x, and the reason we need to give is that angles in a triangle add up to 180 degrees. We're not too far away from the answer now. We're now going to look at this whole quadrilateral here. This is a cyclic quadrilateral since all 4 of the vertices are on the circumference of a circle. You should know that in this case the opposite angles in a cyclic quadrilateral add to 180 degrees. So notice how the y is opposite the 180 take away 2x. So if we add those angles together, we should get 180. We need to give a reason for this as well, so the opposite angles in a cyclic quadrilateral add up to 180 degrees. Now if we take that equation we just wrote down, if we add 2x to both sides, we end up with 180 plus y equals 180 plus 2x, and then subtract 180 from both sides, you'll end up with y equals 2x, which is what we needed to show. There are many different ways of approaching this question, so this won't be the only solution. There are lots of proofs, so as long as you end up with something that follows a logical argument and you give good reasons for each of your steps, you'll probably get the marks. Thank you for watching this video, I hope you found it useful. I've put some suggested grade boundaries here based on previous years, but remember we won't know the real grade boundaries until the exams are actually done. Check out the video I think you should watch next and subscribe so you don't miss out on future videos.